Welcome you all. This is the first video among the series of videos where we will be discussing the designing of static equipment, introduction to static equipment designing. These videos are provided by Christ Engineering Consultancy, your design partner in the designing and detailing of static equipment. So let us start with the general mechanical equipment using in an industry. There are many types of mechanical equipment which are using in an industry, each one performing different kinds of operation. Let us see few examples. First one, the equipment for storage like tanks to store liquid, pressure vessel to store fluid in high pressure. Second one, heat transfer equipment like heat exchanger or heating equipment like boilers. Third one, equipment to pressurize or pump fluids like pumps, compressors, etc. In addition to these, there are material handling equipment like conveyors, lifting equipments like forklift, crane, etc. Equipment inside some chemical reaction takes place like chemical reactor vessels. These are the few examples for mechanical equipment in industries. There are many more like stacks, columns, furnace and lot more. Broad classification of mechanical equipment. The mechanical equipment can be classified broadly into static equipment and rotating equipment. And let us see what is the meaning of static equipment and rotating equipment with a few examples. Static equipment. As in the name, static equipment are those equipment which are static in nature or which doesn't have moving parts. Example, storage tank to store liquid, pressure vessel to store fluids in high pressure, columns, these are tall vessels. Example, distillation column in refinery. Reactors, these vessels used to mix chemicals with the help of mixer mounted on it. Heat exchangers, to transfer heat from one fluid to another. Mounted bullets, to store pressurized gas in high volume. Stack, to dispose waste gases to the atmosphere at high altitude. There is flue and flare stacks comes under this category. These are the few examples of static equipment. In the coming videos we will discuss each one in detail, including the components of them and how to design those equipments in the specified design conditions. Rotating equipment. These are the equipment which do have moving parts. Its main function is to transfer work, like use kinetic energy to transfer fluids or material like in pumps, or use the energy in the fluid to drive the generator coupled with it like in turbines. Examples, pumps, compressor to compress gas and turbines. So let us discuss what is the meaning of engineering design process. By definition, these are the series of steps used by an engineer to create functional product or process. So the static equipment design is a series of steps used by a static equipment design engineer to generate a model of a static equipment with the help of calculations and drawing, to satisfying all its design parameters using suitable design methodology. We will see what is the meaning of design parameters and methodology in the next slide. Design parameters. These are the conditions which are needed to be satisfied to make the equipment suitable for its intended operation. Major design parameters are as follows: pressure, temperature, capacity, dimensions, environmental condition, types of support, materials, external loadings. These are the few parameters which are needed to be taken care of while designing a static equipment. Design methodology. Static equipment shall be designed either by design by rules or design by analysis. Design by rules. It is the design method where the design engineer follows the set of rules and formulas specified in design codes and standards. This method is faster, cheaper and proven by years of successful use of them. But not all design conditions and components can be designed in this method, like fatigue analysis or dynamic analysis. Some components having unique shapes for which it is difficult to find stress distribution under loading condition, etc. Example, in ASME section division 1, the design by rule method is following. Next one is design by analysis. It is a design method where the detailed analysis is performed for the successful design of equipment, usually with the help of computer program FEA, finite element analysis. This method is accurate, can help to reduce consumption of material, and can be used for many components or loading conditions, including fatigue analysis. But this design method is costly, time consuming, and not recommended for cases for which code formulas are available. In ASME section division 2 and 3, design by analysis method is following. Now let us see what is the meaning of design code. Code is a set of mandatory requirements, specific prohibition, and non-mandatory guidance which shall be followed in the design, construct, inspect, and testing of certain product, building or process, in our case static equipment. Codes usually provided by local, state, or federal government or recognized bodies by government. The main purpose of the code is to protect the public by setting up minimum acceptable level of safety. Examples are ASME BPVC, American Society of Mechanical Engineers, Boiler Pressure Vessel Code, IBR, Indian Boiler Regulation Code, AISE Code, American Institute of Steel Construction Code. Now let us look into design standards. Design standard is an established norm or requirement. It is usually a formal document that establishes uniform engineering or technical criteria, methods, processes, and practices. Standards allow for interchangeability of parts, system interoperability, and they ensure quality, reliability, and safety. Example, API standard, American Petroleum Institute standard, TEMA standard, Tubular Exchanger Manufacturer Association standards. Unlike codes, standards are not mandatory unless there is a client requirement to comply. Client specification. In addition to mentioned codes and standards, client may provide their own specification containing specific rules, regulations for designing, construction, inspection, and testing of equipment or process, which shall be followed exclusively for their projects or within their plants. Example, Shell DEP, Aramco standards, CAL standards, Engineers India Limited standards, PDO standards, Petroleum Department of Oman standards, KOC standards, Kuwait Oil Corporation standards, etc. Now, how to design a static equipment. The static equipment design engineer, who is responsible for the designing of static equipment, shall ensure that the equipment shall meet the specified design criteria adhering to specified design codes, standards, and client specification. He or she shall be capable of use good engineering practice or shall have a good engineering judgment while designing the equipment or components under specific design conditions for which the codes and standard doesn't provide adequate guideline or formulas. He or she shall be capable of identify best design methods and use them for the successful design of equipment which is safe and economically feasible. So, a good design is the one that complies all design requirements, taking into consideration of all applicable design parameters, applicable codes, standards, and client specifications. And above all, the design shall be safe and economically feasible. So let us move to conclusion. In this video, we covered definition, classification of industrial equipment and static equipment, along with an introduction to design methodologies, design parameters, codes, and standards. In the future video, we will see how to design different types of static equipment and components in different types of design conditions. So let us see in the next video. please like, share and comment, and also subscribe to the channel for more videos. Thank you. By Christ Engineering Consultancy.